In this video, we're going to look at why even and odd functions are called symmetric functions. It has to do with their graphs. Let's look at what it means to be the graph of an even function. So remember the definition of even function. It's f of negative x has to be equal to f of positive x. So f of a value means the output or the y-coordinate that goes with that x value. So what this equation says is that the two inputs, x and negative x, have the same output with the same y-coordinate. So let's look at a graph. So let's say there's the right half of our graph, and there's the input x. So we look at the y-coordinate that goes with that input. It's up there. And then the other half of the graph, if we look at the input negative x, its y-coordinate is at the same height. They have the same y-coordinate. And so when the right half of the graph, it looks like a mirror image of the left half of the graph, we say it's a symmetric function, and it's symmetric with respect to the y-axis, or it has symmetry about the y-axis. So that's why it's called symmetric. Now, what about an odd function? Remember, the definition of an odd function is f of negative x has to be negative f of positive x. So this says that the two inputs, x and negative x, have opposite outputs, or their y-coordinates have opposite sign. So let's look at a graph. So there's the right half of the graph of an odd function, and there's the input x and its output, f of x. Now, if it's an odd function, then it has to look like this, because the input negative x has to have output negative f of x. So the y-coordinate has to be just a negative y-coordinate that goes with x. Notice the symmetry in this graph. So it's an odd function because f of negative x is the opposite of f of positive x. But where's the symmetry? Where's the mirror? Well, the mirror in this graph, the mirror is just the origin. So we say that an odd function has symmetry about the origin. The origin is the point 0, 0. Or we say that it's symmetric with respect to the origin. Let's look at some specific examples. So the cosine and sine functions are two specific examples that everyone should be familiar with. So I'm going to do a little review of the unit circle. So here's a unit circle. That's a circle with center at the origin and radius 1. So if we look at an angle, positive angle theta, and look at its opposite, the angle negative theta, the point on the unit circle where the terminal side hits the unit circle has x and y coordinate. And remember, the x coordinate is the cosine of the angle, and the y coordinate is the sine of the angle. So for positive theta, that point where the terminal side hits the circle has x and y coordinates, cosine theta and sine theta, respectively. And what about negative theta? Well, the same thing. So the x coordinate of that point is cosine of negative theta, and the y coordinate is sine of negative theta. Now let's look at the x coordinates of those 2 points. Well, if you draw this line this vertical line from one of the top one down to the bottom one, you see that those 2 points have the same x coordinate. So this means that the cosine of negative theta is the same as the cosine of positive theta, and that just means that cosine is an even function. And now if we look at the y-coordinates of those points on the unit circle, so the y-coordinate of the point on the unit circle where positive theta hits the terminal side of positive theta hits the circle, unit circle. Let's call that y. Well, that's y equals sine of theta. And then the one on the terminal side of negative theta, that's just negative y, or the opposite of y. And so this tells us that the sine of negative theta is just the opposite of the sine of positive theta, or negative sine of positive theta. So that means that sine is an odd function. All right, so we know cosine is even and sine is odd, and we can verify that by looking at the graphs. So this is the graph of the cosine function. Notice the symmetry. The right half of the graph is a mirror image of the left half of the graph. So that's symmetric about the y-axis, or symmetric with respect to the y-axis. And then the graph of the sine function has symmetry about the origin. So notice the piece of the graph that's up in the first quadrant is a mirror image of the piece that's down in the third quadrant. And the part that's in the second quadrant is a mirror image of the part that's in the fourth quadrant. So that one has symmetry with respect to the origin, or it's symmetric about the origin. All right, so that was a little review of symmetric functions and their graphs. And we will be using the definitions of odd and even functions throughout this course. And I'll see you in the next video.